Dear students, let's study another important qualitative concept for understanding stable and unstable equilibrium of a charged particle. Here we'll discuss about the equilibrium of a charged particle under the influence of two other external charges. Like say we are having two charges Q1 and Q1 equal in magnitude and of same sign, and another charge Q2 is placed which is exactly midway between the two charges. Now we'll discuss the analysis on Q2 if it is of positive sign and of negative sign about its equilibrium, and say if these charges Q1 are fixed and Q2 is free to move, and let us consider case 1 when Q2 is positive. Now say if Q2 is positive, we can say if it is exactly located midway between these two charges, then it is quite obvious that it will be in equilibrium. Now if we slightly displace the charge Q2 towards right along the line joining the two charges, then in this situation the separation between Q2 and right Q1 will decrease. So the force acting on it due to the right charge, which is force towards left, and Q1 will exert a force onto it which is toward right. It is Fr. And obviously if this distance is less and Q2 is positive, in this situation FL will be more than Fr. And we can simply state due to this Q2 will move toward its equilibrium position again. Similarly, if it is displaced toward left, then again it will have a tendency to come back. So we can simply state FL is more than Fr if displaced toward right, and in this situation Fr will be more than FL if it is displaced toward left. So in this situation we can say the charge Q2 will be in a stable equilibrium because wherever we are displacing it either left toward right along the line joining the three charges, it is having a tendency to come back toward equilibrium position. So we can simply state this implies along line joining charges Q2 is in a stable equilibrium. But let's discuss again the situation when Q2 is displaced perpendicular to the line joining the two charges. If Q2 is displaced away from the line joining the two charges, and if it is positive, we can see this Q1 will repel at Q2, Q1 will repel this Q2, and this Q1 will also repel this Q2, and due to which resulting force on it will be away from the equilibrium position. So it will move away and it won't come back. Similarly, if it is displaced perpendicular to the line joining in other direction, then again it will experience a force due to this Q1 and this Q1 in the direction away from the equilibrium position. So we can say in the direction perpendicular to the line joining the two charges, it will be in unstable equilibrium. Now as Q2 moves away from equilibrium position if displaced perpendicular to line joining charges, this implies it is an unstable equilibrium if displaced perpendicularly. Now this is the situation we have discussed if Q2 is positive. Let's continue on the next sheet the situation when Q2 is negative. Now let's continue with the case 2 of the similar situation when Q2 is negative. We just redraw the situation. The two charges plus Q1 are fixed, and exactly midway between them a charge minus Q2 is placed. Obviously, as the separation of this minus Q2 from the two charges is equal, the force acting on minus Q2 due to the two positive Q1 will balance and it is in equilibrium. Let's see what will happen if it is displaced slightly towards the charge toward right along the line joining. As it is negative charge, this positive will exert a force on it, Fr, and this positive Q1 will exert a force on it toward left, that is FL, and in this situation Fr will be more than FL because this separation is less. That means as Fr is more than FL, it will move away from the equilibrium position, and if we displace it toward left, then in this situation the force due to this Q1 is FL toward left and Fr toward right will be due to this Q1, and in this situation FL will be more than Fr. Again in this situation we can say this Q2 will have a tendency to move away from the equilibrium position. So in this situation we can directly write this implies along the line joining charges Q2 is in unstable equilibrium. And now if we just analyze this Q2, if it is displaced perpendicular to the line joining the two charges, here you can see if it is displaced slightly in upward direction, then this positive charge as being negative Q2, this positive Q1 will attract it, this positive Q1 will also attract it, and net force acting on it will be toward mean position. And if it is displaced downward again, the attractive forces due to Q1 will act and the resulting force on this negative Q2 will be toward mean position. So it will be having a tendency to move toward equilibrium position. So here we can write along direction perpendicular to line joining charges Q2 is in stable equilibrium. This is a situation exactly opposite to the previous case when Q2 was negative, in which along the line joining it was in a stable equilibrium and perpendicular to it, it was an unstable equilibrium. And now as it is negative, along the line joining it is unstable equilibrium and perpendicular to line joining it is an stable equilibrium. This concept is again very useful in various kind of problem. So just take a strong review of such kind of small concepts which are quite helpful for you.